Hello, College Biology. This is another protein video, and in this video we will discuss the general mechanics of protein function. There's a mnemonic we can use to remind ourselves or guide us through this, and that mnemonic is AIR with two R's, A-I-R-R. And they kind of sequentially go through the steps of what's happening. So, first, the A, the protein, in this case our example is an enzyme, but it's true of other proteins. The protein attracts its target particle. Now, because there's an enzyme in this example, the target particle is called a substrate. And the target particle is able to be attracted to the protein based on its specific polarity and shape. In this case, this is an enzyme that undergoes synthesis reactions, so it will take two target particles, and so it attracts two target particles based on their shape and polarity to the enzyme. Well, next we have isomerization. The polar influence of the target particle causes the protein to change its shape. And that's what we're seeing here. So we have these things out on the side, but then once these particles are there, it kind of curls around and surrounds the particles. And this is important because during this shape change of the protein, there are charges moving around, the target particles may be affected by those charges, and during this process, the target particle is altered. So in the case of a synthesis enzyme, that's when you take the two particles together to build something bigger. Now, once this isomerization has occurred, we move on to the next R, release. Because the target particle has been altered and because the protein has changed its shape, their shape and the polarity are no longer complementary to each other, and so they aren't as attracted to each other as they used to be, and so that altered target particle, in this case this product, this substrate that was a substrate, became products, are released. Now, that brings us to the last R. Once the product has been released, there's nothing influencing the polarity of the protein. It can return to its original functional shape, and because that's true, it can attract another target particle again. Now, some students have said, hey, we were only seeing cartoons. What does this really look like? Well, I don't know. What it really looks like is really difficult to determine because we can't see, because light has a hard time bouncing off something so small. So this is a different representation of isomerization, but it's the same idea. This is our enzyme, or our protein. It attracts these two target particles, and once they're in there, the protein it changes its shape. In this case, again, it's folding around those particles. Now, this depiction is a little more accurate than cartoony, although it's still a cartoon. And that's because what we're seeing here, these lines and this like shading, this represents electron clouds. So we're seeing the kind of globby, cloudy electron clouds. Like this is where the electrons are moving around. They're not moving around so much out here, but they are moving around so much in this sort of bumpy landscape. So at the middle of each of those kind of bulges, you would find an atom or a nucleus, and all the electrons around it are giving this protein its shape. So for those that wanted a different way to look at it, this would be like that. Now let's review the general mechanics of protein function. First, the protein attracts its specific target particle due to their complementary shape and polarities. The target particle of enzymes are called substrates, and additionally, the target particles of receptors are called ligands. Then, the protein isomerizes. This means it changes its shape due to the influence of the target particle, and during that shape change, the target particle is also altered. Then, the protein has changed shape, and the target particle has been altered. They no longer have complementary polarity and shape, so the particle is released. And finally, with the particle released, nothing is influencing the bonding of the polypeptide, so it renatures to its original shape. I hope this helps. Struggle well.